Welcome to OlymPYQ, where we learn, solve, and achieve. Today, we are going to explore a concept that looks unbelievably simple on the surface but ends up being one of the most surprising tools in problem solving. It's called the Pigeonhole Principle. Don't let the name fool you. It has nothing to do with birds. It's a powerful idea in combinatorics and logic that appears in geometry, number theory, graph theory, and even computer science. So let's uncover how this tiny idea has such a huge power. The pigeonhole principle says this: if you have more objects than containers, then at least one container must hold two or more objects. That's it. Simple, obvious, but incredibly useful. Let's start visualizing it. Imagine you have 5 pigeons but only 4 pigeonholes. No matter how you arrange them, one of the holes will definitely contain at least 2 pigeons. You don't need equations, you don't need any complex reasoning, it's simple counting truth that guarantees to happen. And this principle forms the base for some of the truly elegant theorem in mathematics. Here is how it appears in everyday's life. In a group of 13 people, at least 2 shares the same birthday months. How? There are 12 months in a year and there are 13 people. So, on the worst case, each person will be having a birthday in the 12 months, and the 13 left out person will have to take any of these 12 months, which makes that at least 1 month will be having a birthday for more than one people. And here is how it works. Now let's try to understand the logic behind it. Suppose we try to place n plus 1 object into n boxes. If each box could hold at most one object, then you would only fit n of them, but we have n plus 1 objects. So one object must break the rule and hold at least 2. This is what mathematician calls a proof by contradiction. We assume every box has at most 1 and quickly realizes that it's impossible, and that's the contradiction means one box must have 2 or more objects. It's a simple observation but leads to a deeper insights. Now let's take it into the geometry. Place 7 points on a circle and we will prove that 2 are within 60 degrees of each other. So for proving this, suppose we place the 6 points equally spaced on a circle. They divide the circle into 6 equal arcs, each having 60 degrees apart. Now imagine adding one more point, the 7th point. The 7th point must fall inside one of those arcs, meaning at least 2 points will end up within 60 degrees to each other. This geometric version looks visual and elegant, but still it's just a pigeonhole principle. It tells us that even in space and shape, counting logic rules everything. Now let's move to a famous Olympiad problem. Among any 6 people, show that either 3 of them knows each other or 3 are mutually strangers. Sounds social, but it's actually combinatorics in disguise. Imagine 6 people at a party. We draw the lines between them, green for friends and gold for strangers. Pick one person, call them A. A has 5 connections, each either a friend or not. So by a pigeonhole principle, at least 3 of those connections are of same type. If those 3 are friends, then those 3 people from the trio are mutually friends. If those 3 are all strangers, then those 3 from the trio are mutually strangers. Either way, the pattern must appear. This is actually the first interesting case of Ramsey's theorem, which studies us how inevitable appears inside a chaos. And once again, it all begins with the pigeonhole principle. Now let's move on to a challenging problem, and the question here it says pick any 10 integers from 1 to 18 and prove that two numbers differ by a multiple of 9. Now to solve this we have a hint. The hint says think about what happens when you divide each number by 9, and we are going to place them into the boxes from 0 to 8. Now the problem of this solution will be done with the help of a pigeonhole principle, and you need to think how you can do it. And the solution of this will be given into the shorts that will be coming soon. So from the birthday months to the geometry, from numbers to friendships, one simple rule connect all of them. The pigeonhole principle. Simple, logical and beautiful. This is OlymPYQ, where we just don't memorize mathematics, we feel it. If you enjoyed this exploration, don't forget to like, share and subscribe for more beautiful maths. And remember, every great discovery starts with a small curious idea.
If you enjoyed this visual proof, make sure to like, share, and subscribe for more math explained visually.